Hello everybody, welcome back to my channel Ray the Chemist. Today I'll be showing you about the types of rocket propellants in our show Rocket Monday. So let's get started with it. So basically rocket fuels or rocket propellants can be divided into three categories: solid propellants, liquid propellants and hybrid propellants. Let's learn more about them. Starting with solid propellants. So if you have ever seen an ICBM, or also known as an intercontinental ballistic missile, this ICBM has to move from one continent and hit a target on the other continent, which means it has to travel a very long distance, for which it requires high thrust, and that's something which solid propellants give us. Also, ICBMs should be very easy to store, because obviously you do not have like, okay, we'll launch the rocket in half an hour, we need some time for refueling. No, that's not what happens in a war. Even those 30 minutes can cost you your life. So it is very easy to store and also can be launched at moment's notice. Next comes is that it is very cheap. So just it's basically a mixture of oxidizer and fuel. Fuel burns and oxidizers is controlling the burn rate of the fuel. This mixture is known as the burn grain. Okay, so this burn grain is very cheap to make, and also it's very simple, just like your rockets which you fire on Diwali festival. Those also use solid propellant because they are very cheap and simple and can be ignited or launched at moment's notice. But after all these good points of the solid propellants or these pros, there is also a very big con, which is the loss of thrust control. You cannot control the thrust, or you cannot even stop the engine once it has been fired in a simple rocket propellant. That's why it is not very much used in as the main engine or the primary engine in the rockets, although you must have seen some solid strap-on boosters used on the space shuttle. So this was it for rocket propellant. Now let's move on to liquid propellant. So right here you can see liquid propellant are having some basic pros, which are it is very easily controllable. So which means you can turn on the engine, turn it off, you can increase the thrust which it is outputting, you can decrease the thrust which is outputting. So all these things make it very suitable for space programs. Also it is reusable. As you can see right here, these are the side boosters which are used on the Falcon Heavy rocket, and you can see these are coming down at the same time in Kennedy Space Center, and which is very 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 nice because you can easily again and again use it, whereas this is not a possibility in the solid propellant. It also is more flexible, which means you can change the fuel as easily as you want, and also you can change how much thrust it is outputting, which also makes it a very good device for space programs. Next, now let's look at its cons. So its cons are basically that it is very complex. You have a lot of things to take care of. There is a fuel tank, oxidizer tank. They both have to be pumped, and then there has to be multiple electronics to feed it into the engine properly. And there is many more things which we have to take in consideration for the uh, better working of the liquid propellant. Now let's talk about some more pros and cons of this liquid propellant. First of all, it is very expensive. When something gets expensive, you can obviously want to use it multiple times. Solid propellant was cheap, so you can add a rocket or add a nuclear weapon in front of it and blast it. That won't cost much. But these liquid propellants are super expensive. Earlier ICBMs also used these liquid propellants, but they are now completely phased out because of the advancements in solid propellants. Also, one more thing which I want to mention in liquid propellants is that their fuel and oxidizer fuel and oxidizer which is used, as I said, here the fuel is contained and here the oxidizer is contained, they are cryogenic, which means they are at sub-zero temperatures. So generally a mixture which is used in liquid propellants, I'll be talking more about them, generally are gases. Like there can be a fuel gas like hydrogen, and there can be a oxidizer which is in 99.9% cases oxygen only. So oxygen in a gas state, if you take these two equal size containers, in one is you have oxygen in the air state, in one you have the liquid state of oxygen, you will be able to fit more oxygen here than here. That is why they're cooled down to such a low temperature that it converts into a liquid and is easy to store. You can store more amount of this fuel in a long period for in a small container. Also, this makes it like you just fuel it and launch it. You cannot wait for a long time, because then this liquid will start vaporizing. Next is I said the cryogenic fuel and oxidizer. This can be eliminated by using hypergolic fuels. Hypergolic fuels are basically all those fuels which can be easily mixed together and they ignite on themselves. I'll be talking about more of these mixtures, hypergolic fuels which are used in rockets, in a next slide. Okay. So before that, let's do the examples of liquid propellant. Liquid propellant can be like RP1. RP1 is basically highly refined kerosene or lamp oil that is very highly refined. They are not like your normal lamp oil. It is very refined, so that even a small amount of it burns at a very high speed and a high rate. Also, it is combined with LOX, also the short for liquid oxygen. Next is LH2 and LOX. LH2 is liquid hydrogen, LOX again liquid oxygen. Next combination, methalox. Methalox is basically methane gas, which is CH4 combined with oxygen gas. One more thing which I wanted to tell you about the LH2 and LOX combination. When these two burns, hydrogen when burns with oxygen, it produces water. So that is the reason you see white plumes or white clouds of condensation forming near rockets when they are using liquid oxygen and liquid hydrogen as their fuels. Next, which I wanted to talk about is the hypergolic fuel, which is dinitrogen tetroxide acting as the oxidizer here, and UDMH, unsymmetrical dimethyl hydrazine, acting as our fuel. When these two combine, they ignite on fire themselves, and this is the fuel which Vikas engine also uses. Vikas is an Indian engine. Okay, it was adapted from a Russian or a French design. Okay, so the Vikas engine also uses dinitrogen tetroxide and UDMH, which are hypergolic fuels, as its fuels. Now is hybrid propellant. Hybrid propellant basically uses a solid rocket fuel, solid rocket grain, in that no oxidizer is incorporated, whereas from the back end of it, let me just draw it for you. On the this is the grain, it has a small opening in it. This is hollow. Here is the fuel grain. The liquid oxygen is pushed through here, which you can actually shut off the engine by cutting off the oxygen supply, and also increase the thrust by increasing the oxygen supply. So this was used in the Spaceship 1 and Spaceship 2 and has very rare uses because of its thrust limits. So that was it for today's video. Please like, share, subscribe and do comment. If you like the video, hit on the like button. If you did not like the video, hit the dislike button. I say you hit the dislike button twice so that I understand that how good bad the video was.